The inverse square law. When we think of learning Flash, we think, oh my gosh, I gotta learn about all these ratios and inverse square law. And look, people make this thing out to be so much more complicated than it actually is, but it is important to understand. And I'm gonna explain to you the only piece of this that's important in layman's terms, or rather, pie man's terms, because I'm a layman and I appreciate when people explain things to me in layman's terms. All this is saying, the inverse square law simply means as your light gets further from your subject, you lose light. Ha! That was so incredibly simple. As the light gets further away, I'm losing light. Wow, that really makes a lot of sense. But the only caveat there is that you're losing light at a quicker rate than you might think you are. And this is what most people think. If I move this light, let's say this is at 1 foot right now, and here's my subject. If I move it 2 feet away, then I get half the amount of light. The only thing that the inverse law is stating is that you're losing actually more than the amount of light that you think, okay? And I'm gonna explain it to you. You'll even understand the math after this. But that's as simple as what it is. Now, in practice, what this means is basically, it's really most applicable when you are, not only when you're moving lights in relation to one subject, but it's most applicable when you're shooting a group of people, more than one person, or a more than one type of subject. So I have an example here. Now, our subjects are roughly let's just assume that they're kind of 1 foot apart. It's really more like 6 inches apart, but let's assume it's 1 foot apart. If I place the flash really close to their heads, let's say that I place the flash 1 foot away from her head, then let's say daughter's 2 feet, and let's say dad is 3 feet. I'm losing light, okay? And I'm losing light at a faster pace than I think, okay? So by the time that light reaches the daughter, I've lost more light. I've lost a lot of light. And by the time it reaches dad, I've lost even more light. What ends up happening is mom is really bright, daughter's in the middle, and dad's really dark. All this means is when I'm shooting a group, the larger the group that I want to light, if I want even lighting on everybody, then I need to move the light further away, okay? I'm gonna explain why right now. Let's actually talk about the formula for just one moment. Why is it called the inverse square law? I hate math. I absolutely hate math. So when people said, you gotta learn the inverse square law, I was like, no, I don't, man. I don't need to learn any math. But then when I actually learned it, I was like, oh, that's really actually quite simple. What is inverse? It just means you invert it, right? You flip, like instead of having 2, it's 1 over 2. Instead of 4, it's 1 over 4. Square simply means you're squaring it. So you flip it and square it. Really simple. The formula is your light intensity is equal to 1 over the distance squared. This is where people kind of get it all confused. Let's assume that at 1 foot from my light source, I'm getting the exact amount of light that I want. We're gonna say that it's 100% light. Really, it's not 100% because I'm losing light between this and 1 foot. But let's assume that at 1 foot, I have 100% of my desired amount of light. Remember what we talked about? You're losing light faster than you think you are. So at 2 feet, my intuition says, okay, at 2 feet, it's double the distance of 1 foot, so I have 50% power. No, it's the inverse square. So I take 1 over 2, and 2 squared is actually 4. So 1 over 4, that is the amount of light I'm left at 2 feet. So from 1 foot to 2 feet, when I double the distance, and this doesn't matter if it's feet or if it's meters, whenever you double the distance, you actually drop much further. So from 100%, I drop to 25% power. Now, let's say from 2 feet all the way to 4 feet, I would think that from 2 feet to 4 feet, well, it's 4 feet is double the distance of 2 feet. So I'm gonna have half the power. I'm gonna have 12.5% power. But no, it's again, anytime you double the distance, you cut it in a quarter. So at 4 feet, I have 6.25%, which is 1/4 of where I was at 25% at 2 feet. This is all the inverse square law means, is that you take the distance, you square it. So at 1 over 1, this is my full power. This is where I have my full setting. At double that distance, it's 1/4. At 3 feet or 3 meters, whatever you're using to measure, It's now 1 over 3 squared, so 1 over 9. That's my power left, which is 11%. At 4 feet or 4 meters, I'm at 1 over 4 squared, which is 1/16th power, 1/25th power, 1/36th power. Every one of these has a corresponding percentage. Now I'm getting 2.78% of that original 100% at 1 foot compared to at 6 feet. So the light is falling off at a very dramatic pace. But here is the part that should make sense to you. From 1 foot to 6 feet, this light fall off is incredibly dramatic. Look at this. We're going from 100% down to 2.78%, okay? We're losing the majority. 97% of our light is gone. But from 6 feet to 7 feet, the difference there is only 0.6%. From 7 feet to 8 feet, the difference there is only 0.4 or 0.5%. So what happens is the further from the light source, the less fall off you're actually getting. And that's why, let's say when we're talking about the sun, well, is how many billions of miles away from us. Even though I'm standing, let's say I'm standing 1 mile closer to the sun than somebody else, in relation to how far that light is away, that 1 mile difference between me and another person in relation to the sun is nothing. So the amount of light that I'm getting versus the amount of light that is reaching them is identical. It doesn't really make any bit of difference. But with a flash that's placed relatively close, that distance would make a difference. And we're going to show you that in practice. So what are the takeaways? Inverse square law, simply put, you're losing more light than you think you are as you move the flash away from your group or away from your subject. When you're lighting a group, if you want even light from left to right or from right to left, you need to place the flash further back so that everybody is at a roughly and approximately same distance to the light source. And then you'll get even light on everybody. If the distances between them are different, then that's where it's going to change. And if you want to know the math, we'll simply take the intensity is equal to 1 over the distance squared. So the distance from the light source squared. That's it. That's it. Now we're going to show you what it is in practice, and hopefully by the end of this, it's going to make so much sense. You're going to be like, oh my gosh, why didn't anybody just say that your light gets less powerful more quickly than you think it does? I don't know why anybody said that, but I'm saying it to you now. So let's go to the next video.